You're about to pick up your phone. Your right hand reaches for it before you even think. You don't decide which hand to use. Your brain decided for you about half a second ago. But for roughly 800 million people on this planet, that automatic reach goes the other way. And here's the strange part. Nobody knows why. You're right-handed, or you're left-handed, or maybe you're one of the rare people who can use both. But have you ever stopped to ask, why can't you just choose? Why does one hand feel natural and the other feel like you're wearing a clumsy glove? The answer is buried 500,000 years deep in your evolutionary past, written in ancient teeth, painted on cave walls, and encoded in a puzzle that scientists still can't fully solve. So let's start at the beginning. The mystery of the 10%. About 10 to 12% of the human population is left-handed. That's roughly 1 in 10 people. And this percentage has remained remarkably stable, not just across countries, but across thousands of years of human history. In the Netherlands, about 13.2% of people are left-handed. In the United States, it's around 13.1%. But everywhere you look, left-handers are always the minority. The question is, why? If being left-handed is perfectly normal, why isn't it 50-50? Why doesn't evolution just balance things out? And if being left-handed is somehow disadvantageous, why hasn't it disappeared entirely? This is the evolutionary puzzle that has fascinated researchers for decades, because left-handedness appears to come with real costs. Studies have found that left-handedness is associated with certain fitness costs, poorer health, slightly reduced height, even reduced longevity in some populations. Left-handers are more likely to have certain neurodevelopmental conditions, and they live in a world overwhelmingly designed for right-handed people, from scissors to power tools to the very layout of a classroom desk. So if left-handedness is costly, why does it persist? The surprise advantage. Imagine you're a fighter. You've trained your whole life. You've sparred with dozens of opponents. You know exactly how a right-handed person moves, the angle of their jab, the way they circle, the footwork they use. Now imagine you step into the ring with someone who moves completely backwards. Every punch comes from the wrong side. Every defensive move you've practiced is suddenly useless. That is the experience of fighting a left-handed opponent. This is called the fighting hypothesis, and it's one of the leading explanations for why left-handedness has survived. The idea is simple. Left-handers have a surprise advantage because right-handers, who make up the vast majority, simply don't have enough experience fighting against them. A 2019 study analyzed over 13,800 professional boxers and mixed martial artists, one of the largest studies of its kind. The results were striking. Left-handed fighters consistently had greater fighting success. They won a higher percentage of their fights. They were objectively better fighters. And it wasn't just men. The same advantage held for female fighters too. This isn't just a modern phenomenon. In combat sports like tennis, fencing, and baseball, left-handers are overrepresented at the elite level. Being left-handed in an interactive sport isn't a disadvantage, it's a weapon. But here's where it gets really interesting. The rarity advantage. The fighting hypothesis relies on a concept called negative frequency dependent selection. That's a fancy way of saying a trait becomes more valuable when it's rare and less valuable when it's common. Think about it. If left-handers made up 50% of the population, everyone would have plenty of experience fighting them. The surprise advantage would disappear. But at 10%, left-handers remain unpredictable, a tactical edge that only exists because they're the minority. This creates a natural balancing act. If left-handers become too common, their advantage shrinks. If they become too rare, their advantage grows. The system tends to settle right around that 10% mark. Evolutionary biologists call this a balanced polymorphism, a stable equilibrium where two forms of a trait coexist because each has its own niche. But is fighting really the whole story? Some researchers have questioned whether combat alone can explain the persistence of left-handedness. After all, not every human is a fighter, and the advantage only works in one-on-one combat, not in group warfare, where coordination matters more than surprise. So there must be something else going on. The genetic clues. Your handedness is partly written in your DNA. Twin studies estimate the heritability of handedness at about 25%. That means about a quarter of the variation in whether you're left or right-handed comes from your genes. The rest comes from environment, development, and chance. If both your parents are right-handed, you have about a 10% chance of being left-handed. If one parent is left-handed, that chance jumps to 18 to 22%. If both parents are left-handed, it's around 27%. The maternal effect is stronger, suggesting that some of the genetic influence might be linked to the X chromosome. And in 2024, researchers identified 41 genetic loci associated with left-handedness. Many of these genes are involved in brain development, specifically in the formation of microtubules, the tiny structures that help build the brain's neural architecture. Here's the crucial point. Handedness isn't controlled by a single left-handed gene. It's polygenic, influenced by many genes, each with a small effect. And these genes don't just affect your hands. They affect the very structure of your brain. The brain asymmetry. Your brain is not symmetrical. The left and right hemispheres look similar, but they do different things. Language, for example, is predominantly processed in the left hemisphere for about 85% of people. Spatial awareness and face recognition lean more toward the right. Handedness is a behavioral manifestation of this brain asymmetry. In right-handed people, motor control is strongly lateralized. The left hemisphere, which controls the right hand, is dominant. In left-handers, the brain's organization is often more symmetrical. There's less of a clear division between left and right. A 2024 study using brain imaging data from nearly 30,000 participants found that left-handedness is associated with reduced leftward asymmetry in functional brain connectivity. In other words, left-handers' brains are wired differently. Not worse, just different. This difference might explain some of the cognitive patterns associated with left-handedness. But it also raises a deeper question. Why does this asymmetry exist at all? The ancient evidence. Right-handedness is ancient, really ancient. Archaeological evidence suggests that the right-hand bias has existed for at least 2 to 3 million years. Some researchers believe it may go back as far as 7 million years, to the very dawn of human evolution. How do we know this? Ancient teeth. In 2009, researchers analyzed 592 cut marks on 163 teeth from Homo heidelbergensis, an ancestor of Neanderthals, found in a cave in northern Spain. These ancient humans used their teeth like a third hand, clamping down on meat or other objects while cutting them with stone tools. The marks left on their teeth told a clear story. Out of 19 individuals, 15 appeared to be right-handed. None appeared to be left-handed. That's a 90 to 10 ratio. Exactly the same as today. But there's another piece of evidence, and it's even more personal. In caves across France and Spain, painted during the Upper Paleolithic period between 30,000 and 10,000 years ago, prehistoric humans left behind something extraordinary: handprints. To make these prints, artists would blow pigment through a tube onto the wall while pressing one hand against the surface. The hand on the wall wasn't the one holding the tube. So by analyzing which hand was pressed against the cave wall, researchers could determine the artist's handedness. They studied 507 handprints from 26 caves. What they found was remarkable. 23% of the handprints were from left hands, meaning they were made by left-handers. Wait, 23%? That's much higher than today's 10%. So what changed? The researchers suggested that in the distant past, environmental pressures to conform to right-handedness may have been lower. But over thousands of years, as human societies became more cooperative and tool use more standardized, the pressure to be right-handed may have increased. Still, the evolutionary forces that maintain the 90 to 10 ratio remained constant. The balance between the advantage of being rare and the cost of being different kept the numbers stable. The modern mirror. But surely this was just one unusual group? You might be thinking, this doesn't apply to me. I'm not a fighter. I don't live in a cave. Why should any of this matter to my life today? Here's the thing. You do live with the consequences. Every time you use a pair of scissors, open a door, use a can opener, or sit at a desk designed for a right-handed person, you're experiencing the legacy of that ancient 90 to 10 ratio. The world was built for the majority. The minority adapts. But here's the twist. The creativity myth and the real advantage. You've probably heard that left-handers are more creative. It's a popular belief, one that's been repeated for decades. But is it true? In 2025, researchers conducted a comprehensive meta-analysis of nearly 1,000 studies on handedness and creativity. Their findings were clear. Left-handers are not more creative than right-handers. In fact, on some measures of divergent thinking, right-handers may have a slight advantage. The belief that left-handers are more creative? It's a myth. Small studies with small sample sizes suggested an advantage, but when the data was aggregated, the pattern disappeared. So if left-handers aren't more creative, and they face real disadvantages in a right-handed world, why does the trait persist? Because evolution doesn't care about creativity. Evolution cares about survival and reproduction. And in the environments where our ancestors evolved, environments filled with conflict, competition, and the constant need to defend themselves and their kin, the surprise advantage of being left-handed was enough to keep the trait alive. The kin selection twist. In 2024, researchers introduced a new layer to this puzzle: kin selection. Kin selection is the idea that evolution can favor traits that help your relatives, even if they cost you personally. It's the logic behind altruism, why an animal might sacrifice itself to save its siblings. The researchers asked, what if left-handedness isn't just about individual advantage? What if it's about how it affects your relatives too? If combat happens within groups of relatives, say, brothers fighting brothers, then left-handedness is selfish. The left-handed individual gets the surprise advantage, but their right-handed relatives pay the cost. In this scenario, higher relatedness would decrease left-handedness. But if combat happens between groups, where left-handed individuals fight outsiders to protect their kin, then left-handedness could be altruistic. The left-handed fighter takes the risk, but their relatives benefit from the protection. This is still theoretical, but it shows that the evolution of handedness isn't simple. It's shaped by social structure, relatedness, and the delicate balance between selfishness and cooperation. The unresolved question: so why can't you naturally use your left hand? The answer is written in your genes, your brain structure, and your evolutionary history. But it's not a complete answer. Because despite decades of research, scientists still don't fully understand why the 90-to-10 ratio exists. The fighting hypothesis is compelling, but it doesn't explain everything. The genetic evidence is clear, but it's only part of the story. The ancient handprints and teeth tell us that this pattern is ancient, but they don't tell us why it started. The truth is, handedness remains one of the great unsolved puzzles of human evolution. And that's okay. Because some mysteries are more interesting than answers. The closing mirror. You're about to put down your phone. Your right hand reaches for the table before you even think. Or maybe your left hand does. You didn't decide. Your brain decided for you. Acting on instructions written over millions of years, shaped by ancient battles, rare advantages, and the strange mathematics of evolution. The hand you use isn't a choice. It's a fossil, a living fossil, embedded in your nervous system, connecting you to every human who ever lived, from the cave painters of prehistoric Europe to the boxers of ancient Rome to the person sitting next to you right now. You can't naturally use your left hand because your ancestors couldn't either. And somehow, that makes it a little more natural than you thought.